Alright, ladies and gentlemen, we're dealing with 9.2, day 1. This is arithmetic sequences. It looks like arithmetic, but it's arithmetic. Alright, anyway, here we go. We're going to determine if a sequence is arithmetic, find the given term or terms of a sequence, and then find a formula for that sequence. Alright. Okay, by definition, an arithmetic sequence is a sequence where the difference between consecutive terms is constant. Okay, that constant is a common difference and is denoted by a variable d we're going to use. Okay, now that maybe sounds really fancy, but basically all it means is, like if they take this first example here, 8, 10, 12, etc. Well, as long as the difference between consecutive terms is constant, so to go from 8 to 10, well, that's simply plus 2. 10 to 12, also plus 2, etc. So basically, since this guy goes up by 2 each time, this is an arithmetic arithmetic sequence, and the common difference in this case is a 2. Basically, it's what you add to get from one term to the next. I know that's a difference, is what it says in the definition, but realistically what they mean is what do you add to get from one to the next. Okay, so 15, 12, 9, 6, 3. Well, again, if we get to one to the next, that's a subtraction of 3. That's a subtraction of 3. And so basically this example is simply showing that the common difference could be negative, and I think it makes a little more sense this way, that we use d as positive if it's going up, negative if it's going down. Okay, this last one, from 14 to 10, you can quickly see that's a minus 4, but then 10 to 4, hey, wait a minute, that's minus 6, that's minus 8 right there, and that's a minus 10, so basically there is no d, because this guy is not arithmetic. Okay, so if you don't have a nice add or subtract each step of the way, whatever we're talking about today doesn't apply, so don't fall into that trap. Alright, well, as we've done in the previous section, we want to find a formula for these sequences on occasion, and realistically we've done it before, we just didn't call them arithmetic. I am going to formalize it here with a formula you can see down there toward the bottom, but okay, this one, hopefully pretty simple. I've got 8 to 10 is plus 2, and you can see it's a simple plus 2 the rest of the way, so I'm not going to bother writing those. But, okay, now the formula I kind of went with before, or the kind of way I would do it before, is I would say, hey, okay, well, let's just take the first one, and then figure out what I need to do to get from one to the next. Okay, so, okay, my common, it's a plus 2 each time, so I'm going to take 2, and then what I'm going to do from there is add it n number of times, but remember, I don't want to add it the first time, because I'm already where I started. So I would subtract 1 from there, just to account for the fact that I don't do it for the first term. Okay, and then from there we could then sort it out. Okay, of course that's a 2n minus 2, so I get a 2n right there, the minus 2 gets together with an 8 and gives me a positive 6. Okay, and again, as soon as I get that, I say to myself, hey, okay, does that actually work? So I plug a 1 in for n, 2 times 1 is 2, plus 6 is 8, 2 times 2 is 4, plus 6 is 10, and I start feeling pretty good about what I came up with. Okay, so to formalize this, notice that this right here, a sub n, the 8 right here is my first term, so a sub 1 for first term. And then we add it to that. Okay, now the formula I'm going to give you has got these two things switched. Okay, we're going to take the number of terms minus 1, and then we're going to multiply this by 2. Okay, now using the vocabulary that we already mentioned, this plus 2 is our common difference. So again, we're going to use the letter d for that. So basically there's a formula for any term of an arithmetic sequence. It's kind of a nice formal thing instead of the more intuitive way we've done it up until now. Okay, I'd like to do a couple more examples of this finding a sub n, because the given conditions make it either harder or easier depending on what you're dealing with. Okay, well here I've given you the first term is 40 and then the fourth term is 16. Again, that's what that fancy notation means. Alright, so basically I can use that formula that I just had. I'll rewrite it for the sake of, so you see it a few times. A sub n equals a sub 1 plus, and in case you're wondering, yes, you need to memorize it. Alright, got that formula right there. Alright, so, okay, now in this case, I've got a sub 4. So basically what I'm dealing with here is I've got a situation where n equals 4 for this formula. Alright, so the a sub n is really basically saying a sub 4 equals a sub 1 plus 4 minus 1 times d. Alright, so my a sub 4 is 16, my a sub 1, as it says right there, is 40. Okay, 4 minus 1, I'll check on my calculator real quick, and that's a 3, and then d right there. Okay, so basically, I can figure out my d pretty quickly. Subtract the 40 from both sides, gets me a negative 24, equals 3d, and then very quickly I have d equals negative 8. Okay, and again, thinking about this formula, I don't need n, but I do need d, and I need my first term. Well, now I've got D. I had my first term the whole time, so I'm ready to write my formula, final answer sort of thing. So I've got a sub n. Again, I'm still finding the formula for a sub n, so I don't want any other numbers in there other than the ones that I just figured out. Alright, so a sub n equals 40 plus, again, 1 less than the term number that I'm on, and then it can be times negative 8. Okay, and again, it's kind of nice to clean this mess up a little bit. So a sub n equals 40. That's an a, believe it or not. Alright, now be careful because you're distributing a negative, so actually this is a negative 8n and then a positive 8. So now my final a sub n, and realistically I don't care if you put the constant first or the variable first, it doesn't really bother me, but whatever the case, I kind of like the variable first, but that's just me. Negative 48 plus, sorry, negative 8n plus 48. There you go. And that would be your formula then. Alrighty, this next example, we've got a bigger issue because we don't have the first term already. And again, just to try to drive it through your skulls as best as possible, a sub n equals a sub 1 plus, that's a plus sign, believe it or not, alright, n minus 1 times d. Okay, again, a sub n is what's going to be on the left side, but I need a number for a sub 1 and I need a number for d, and then I can plug those in. Okay, and right now I have neither. Alright, so you can do this a couple different ways. I kind of like almost a fill-in-the-blank sort of way for this. We can kind of reassign the 5 and the 11 as lower numbers. Kind of if I reassign this as a 1, and then I can adjust this accordingly. Dropping this by 4 would mean dropping this by 4, and that becomes a 7, and then I could work the formula there and just kind of work my way backwards. But I don't know, to me that seems like it gets a little confusing changing things around. So here's actually what I like to do, kind of maybe a more intuitive, maybe a more visual approach, but here we go. So here would be the first term, I'll just leave a blank for it, and then there's the second, and there's the third, there's the fourth, and then there's the fifth. Okay, so I'll label it a sub 5, and I'll put the 18 right in there. Okay, and then here's my 6th, 7th, 8th, 9th, 10th, and again there's the 11th, which is the other number that I have. This gives me a 39 right there. Okay, now the one I really care about is a sub 1. Okay, now what I need to do is also figure out the d. So these two things are the things I want to figure out, so here it is. Okay, now looking at this, well, I have 18, and remember, I'm dealing with an arithmetic sequence, so what I need to do is add or subtract. In this case it's bigger, so it's obviously adding each time the same number until I land there. So, well, brace yourselves, here it is. Basically, here's what goes in my head. I go, well, I'm at 18 here, how many steps do I need to get up to there? Well, just simply count. 1, 2, 3, 4, 5, 6. So there are 6 of the d value, whatever that is, that take me up to the 39. So from there, I can basically just say 18 plus 6d equals 39 and solve that equation. Subtracting the 18 gives me a 6d equals 21, and then yeah, that's a decimal, but deal with it. D equals 3.5. Okay, so basically each step of the way I'm going up by 3.5. Okay. So what that allows me to do now is take that 18 and work my way backwards down to a sub 1. Okay, I could use the formula if I wanted to, but maybe again, if this feels better to you more intuitively, here we go. Take 1, 2, 3, 4 steps down back to a sub 1. So basically I have to take now the 18, now I have to subtract, because I'm going the opposite direction, 4 of the d's, which again is 3.5, and that'll take me to a sub 1. Alright, so just sorting this mess out, 18 minus, well, 4 3.5s is 14, equals a sub 1, so I know my a sub 1 is 4. Alright, so it puts me a 4 right there, but now I have the 2 bits of information I need for my formula. Alright, so now I can go to work plugging things into there. Let's go back to blue. Alright, let's see if I can squeeze it in here. So a sub n equals a sub 1, which is 4, plus n minus 1 times the d, which is a positive 3.5. Alright, and then again, distribute, kind of combine like terms, do what you can to clean it up. 4 plus 3.5n minus 3.5. So again, depending on whether you like the constant first or the variable first, you could either start with a 0.5 plus 3.5n, or just my personal preference, 3.5n plus 0.5. There would be your nth term. Takes a little more work to get there if you're not starting at the beginning, but it's still very possible. Alright, now the book's going to ask you to find the first 5 terms of an arithmetic sequence. Admittedly, 5 is fairly arbitrary. They could have said 12 or 2 or whatever, but 5 is a nice kind of normalish number, so let's go with that. Alright, Now, depending on the starting information again, if I'm given the first term and a common difference, well, this is a pretty, hopefully, simple scenario for us. Well, a sub 1, what could that be? Oh, look, it's 17. Alright, and then a sub 2, again, the whole thing behind what d means is that's what I have to add or subtract based on the sign to get from one number to the next. Well, since I'm doing a d of negative 4, well, 17 and then minus 4 takes me down to 13. And then a sub 3, well, let's see if I can subtract 4 to get 9. My fourth number then is going to be 4 less than that, so 5. And then finally my a sub 5 is going to get me down to a 1. So there's your first 5 terms. Doesn't take too much effort to get that. Alright, now here I'm not given that nice information, so again this takes a little bit of work, so kind of just to do it again. Alright, here's my first, second, third, fourth, which I have is 24. There's my a sub 4. Again, I care about a sub 1, and actually eventually I care about the first 5, but here we go. That's 4. Here's the fifth one, here's the sixth one, 7th, 8th, and then finally my 9th, a sub 9, is negative 11. Okay, now hopefully it's pretty clear here that these numbers are getting smaller, so I'm definitely going to have a negative d, but regardless whether you notice that or not, same basic idea holds. I've got 1, 2, 3, 4, 5 steps to get down to negative 11. So 24 plus 5 of those steps takes me to negative 11. Again, solving pretty quickly here. This gives me a negative 35, so my d ends up being negative 7. Okay, and again, going the other direction now. 1, 2, 3. So I have to take 24, and I'm going to go minus. Again, it's negative because I'm going to the left. I don't care that d is negative right now. I need to subtract 3 steps worth of d to get to my a sub 1. The line to separate those. So 24, and see the negatives cancel each other out here, or make a plus, whichever way you want to think of it. And that, so I've got a sub 1 equals 45. Okay, so notice I get the bigger number that I was expecting, because down here is a pretty small number, so I know I needed a pretty big number to start with in order to pass through the 24 on the way there. Alright, that being said, my first 5 terms should be pretty simple. A sub 1 is 45. And we'll just take it from here. So a sub 2, again, I figured out my common difference is 7, so all I have to do now is subtract 7 each time. So it gets me a 38. A sub 3 subtracting 7 gives me a 31. A sub 4 minus 7, by no coincidence whatsoever, give me the 24 that I was expecting. And then a sub 5, 7 off of that, lands me at 17. Alright, so there's your first 5 numbers. Again, fairly arbitrary that they asked for 5, but since that's what's asking for, there it is. Alrighty, now if you have to find the first 5 terms and you've got one of these recursive ones, it's actually a little bit nice that they actually gave you the first one. So kind of my final answer over here, a sub 1 equals 64, I'm 20% of the way done. Alright, and then again, you may not need to see this, but just for the sake of argument, remember that ak plus 1 really just means the next one. So the next one right now is going to be the second one. And then again, that's just the previous one, a sub 1 in this case, minus 12. Well, of course, a sub 1 is right there, 64. So a sub 2 equals 64 minus 12, and I'm pretty sure 64 minus 12 is 52. Okay, so then there's the second half of my answer. Okay, now hopefully this won't be too much of a shock here. Notice, basically I just want to take the previous one and subtract 12 to get to the next. So if I want the third one, I just really have to look at the previous one up here, the 52, go minus 12, and that lands me at 40. Okay, and I can very quickly just follow that out, give me a 28. And then a sub 5, 12 off of that, is going to land me at 16. And then there's the first 5. Again, we could keep going infinitely if you'd like, but again, we're only asking for the first 5, so there they are. Alright, now this happens kind of late in the problem set that I'm going to assign for homework off of this one, but it's actually one of the more basic problems, but here it is just in case anybody's going to freak out over it. Alright, so find the indicated term. The book doesn't exactly say it, but we're going to assume an arithmetic sequence. And here it is. So if I give you the first term and the second term and then ask you the 15th, okay, well you could do the little blanks system that I did earlier and it would eventually work, but I think that is a little bit of overkill because quite honestly, well, if I go from my first to my second, that's pretty easy to figure out. From 3 to 10.5, that's 7.5. Alright, so from there I can just use the formula. So my nth term, in this case, well, let's write it out again just to make sure you wake up with nightmares of this formula. Alright, so a sub 15, again that's the 15th term, is going to be my a sub 1, which is 3, plus Again, since I want the 15th term, I just plug in a 15 right there, minus 1. So if you plugged in a 14 there instead of just writing 15 minus 1, I wouldn't fault you for that. And then that times the d, which of course is 7.5, and then basically there you just work that out. So AC15 is equal to, after I crunch all those numbers, 108. Sorry for the messiness right there, but there we go. Alright, here's our assignment. Okay, okay, again, thinking of the whole enough sort of thing, the problems are definitely tougher near the end. So if you do the first one, like, woohoo, I got it, well, go to the end and try the one at the bottom of the problem set before you totally have an overconfident moment. But there it is. See you in class.